While we're waiting for the other few, let's go ahead and look at review questions from yesterday. And this is another one. I got a couple of them. I kind of jumped the gun on, and I don't know why I did that because I knew I wasn't going to get the automation done before we got to these questions. But anyhow, switches port gig 01 has been correctly enabled with port security. The configuration sets the violation mode to restrict. A frame that violates the policy, the port security policy, enters the interface, followed by a frame that does not. Which of the following answers correctly describes what happens? And this is one that I tried to set up and show yesterday when we did this configuration. So the switch puts the interface into air disable state. The switch generates a syslog messages about violating traffic for the first frame, and that was the frame that violate was the first one. The switch increments the violation counter, and it does that. We've got that one. And then B, it's going to generate the syslog message and increment the violation counter. And that's what restrict does. And the protect, restricts, shutdown, PQRS, alphabetic order. Protect just simply drops things. Restrict does the same thing that protect does, except it sends you messages and increments the violation counter. So when you go and do the show port security, you can see what's going on with it when we do those things. So yeah, large amounts of global and shutdown puts it in a disable mode. Back to the other one there. Large amounts of global synchronization means what in terms of bandwidth usage? Low efficiency, high efficiency, nothing. It's normal as long as the speed of the connection is not adversely affected. The excessive amounts of global synchronization should not be a concern. Yeah, we'll go with A on that one, that we have this issue here. Anyhow, other questions here. This is mine. Cisco software defined access, which is the new way to do software defined networking. We kind of have a progression, and I'm probably going to have to show you that progression today because one of the machines at Cisco, and I'm going to have to, I want to do some demos on this using Ansible, actually, because it's open source free and you don't have to put anything on the device. But anyhow, back to these, the software defined access, which device which term refers to the device's cabling along with the configuration, the things you can reach out and touch. It's going to be the underlay. We're going to have an underlay, an overlay, and a fabric. And then we're going to use VXLANs, more LANs, in order to get from one to the other. When we do the lesson, we'll probably go maybe a little bit deeper than you need. The automation that you need at the CCNA level is to know about it, know a little bit about it. That's the entering argument. And then as you progress, they actually have a test, not a certification, but a test to do a class and a test for automation if you want to do that. Which of the following is required when configuring port security with sticky learning? And there's a lot of thrown in here. Yeah, do we really need all this information? The key to the question, and this is how you read their questions, which of the following is required when configuring port security? Sticky learning is going to be a configuration. But what is the single requirement to get port security going? Setting the maximum number, enabling port security, defining the specific allowed MAC addresses, or all of the above. Yeah, and the very first thing you got to do is enable port security. Port security, two-step process. First you enable it, then we configure it. The sticky, no, it's not. The sticky is just because the default is dynamic MAC addresses. The sticky here is one of those meaningless things to throw you off. I don't know what they call it. Yeah, tricky, and they'll do that to try to throw you off. what are they actually asking? And then that's, to me, where all of the practice questions, the more practice questions you can do, the better. What are they really asking? What's going on here? So, the requirement, well, sticky learning is not a requirement. That's a modification that we can use. The dynamic is the default for these things. The defaults were, we didn't have any aging. It was turned off by default, but we have dynamic addresses, which aren't going to age out, because when we enable port security, we turn off aging, the 300 seconds, the 5 minutes, maximum of 1. And the violation mode is going to be shut down. So those are the defaults if you just turn it on. But two-step process, turn it on, and then you can do the other configurations if you want to do that. What does dynamic ARP inspection, DAI, require in order to operate correctly? DNS snooping database, IP, verified source, MAC address table, DHCP snooping database, or DHCP snooping bindings, adjacency table. Yeah, I'll go with D. And this is what you're going to see. It's really the bindings base. Which link, Kenneth, for these? Yeah. I was presuming that's the one you want. That's where we are right now. The one that Brandon just put in. Which one of the following is not a port security mode? I hate not questions. I don't know about you. I hate not questions. But anyway, which is not? Protect, shut down, disable, restrict, defend. Yeah, E. And which other one? And they select 2 here. And C. P, no Q. R, S, protect, restrict, shut down. What is the fundamental purpose of IEEE 802.1x? Eliminating switch loops, authentication, authorization, malware, and spoofing protection. Yeah, B, authentication would be its primary purpose for these things. Which statement below describes best effort service? All are, did not say what device. You're talking about for the 802.1x? For IEEE? IEEE is, that's the definition. The IEEE 802.1x defines defines IEEE is the organization that maintains that standard. 802.1x is an authentication protocol. It doesn't matter whether you're using it on a port, and that's what it was originally designed for, was port authentication, or a wireless access point. But you're using it with a third-party radius server in order to do the configurations. For this one, does that answer the question there, Jamal? Okay. So in this one, and we got an A here, best effort is all traffic is created equal, which is going to be the default. AAA stands for, pick 3. Those are 3 A's there, I guess. A, B, and C for this one, exactly, for that. Which of the following is not considered, this is mine, not considered one of the planes used to describe operations of network devices? And it's going to be the application plane. And then we're going to talk about the application plane. We're going to have the management plane, control plane, data plane. And this is the way that we're going to break things out for automation. Accounting is what you did after you got there, when we send the logging and things like that. Look at the logs for what a user did while they're logged on. So authentications when we prove who we are. Authorization is what you did, and accounting is recording what you did while you were online. Which two technologies can be used to create site-to-site VPN connection: IPsec, SSL, DNS, NTP. Yeah, we'll go with A and B here. IPsec, DNS, and NTP, we know they're not going to be. I mean, even if you didn't, and you do know, but even if you didn't, you know what these two do, and it has nothing to do with a site-to-site VPN. Blank is a means of encrypting a session between two hosts through the use of digital certificates, which are based on asymmetric key encryption. CHAP, Radius, DMZ, SSL. Yeah, I think I like Ray's SSL and Jamal's SSL here for that. Secure socket layer. CHAP is Challenge and Handshake Authentication Protocol, which is been around for a while. It's kind of a, yeah, you probably already know about it, but the device, the authenticator, sends a random character string, a challenge to you. You encrypt the challenge with your password, send it back, and then they decrypt it. If it can decrypt the challenge, then you're in. Otherwise, you're not. Another method that's used in order to not send the password across the network, and a lot of effort there, so that we're not actually transmitting the password. We're doing other things with the password, and indirect, and all these authentications are going to be indirect when we do these things. Kind of like we talked about Kerberos yesterday. We set the authenticator, some encrypted, but the encrypted part is encrypted with your password. The domain controller decrypts the encrypted part with the password that it's got on file. If it's good, it's good. Otherwise, you get a reject for those things. An industry standard protocol that simply provides authentication service: TACACS, SSL, Radius, or TLS. Yeah, Radius is the open source one. TACACS, Cisco proprietary. A blank VPN allows users to have access to the corporate firm remote locations. Yeah, look for the plus sign, the TACACS plus, exactly what Matthew said there. So a blank VPN allows designated users, and now I got it up here. B, and I was reading the answers wrong here. Client to site VPN is what we would use for those. You've not answered one question. Oh, which one question didn't we answer? You probably answered it and I didn't mark it. Yeah, here. Oh, skipped right over this one. Switch SW1 needs to be configured to use DHCP snooping in VLAN 5 and only VLAN 5. What commands must be included? Select 2, and yeah, we got a C and a D over here. It's like port security. First we turn it on and then we apply it to a VLAN. We could do that, and I think now then we can get the 100% on this. So we have those. And let's go to the question. Let me go to my remote here, and I guess fortunately, unfortunately, we're going to be here a couple of times today. What I think you're asking is, why do we need this deny? Is that a true statement?
The first one there, yeah, because they were saying that they're still able to get through, but isn't that denying all telnet traffic?
But the first one just denies telnet traffic, and if you go up and go back up, and what I'll say, and this denies everything else. So the first one just denies, yes, for everybody, but just port 23. 65,536 ports, leaves a lot of other ports available that they can get through. The other guys, and back up to the trouble ticket, which you don't have to do. This is actually the way that the T-shoot used to be. They give you a trouble ticket and you have to go. When you, while you documented one was resolved, the user on PC2 Tom requested your assistance troubleshooting another problem. The network security policy restricts access to secure a particular device, a server here, so that only Tom and management users are allowed to access it. Tom can connect to it. That's good. can connect to secure because he's supposed to be able to. The server logs on secure indicates that users from support have also been accessing the server. It doesn't say here, and this one may be one of those that you have to make assumptions that we always tell you not to make. Have been accessing the server. It doesn't say how or what services, and it doesn't say what services are running on that server. Is it a web page? Is it a whatever else? It just that they're accessing it in some way. And we're going to make the presumption, again, presumptions here we tell you not to, but you got to do some here for this lab anyway, that it's something other than Telnet. States that access
That makes
control.
sense.
Say again?
So that part makes sense because, you know, the way it's worded, it's making it
know.
seem like they could tell, like, you
Yeah.
think they'll put security so they can't
Yeah.
access it any other way. But yeah, that makes sense.
Okay, so okay, if that makes sense, then we'll go into automation here for a little bit. But yeah, the something else, and again, there are unstated possibilities, I guess, would be what we talk about in that trouble ticket. And not really so much. The first one there should stop any telnet traffic, but that's it. You know, is there's a web page that they're getting to, or other things that they may be getting to, maybe file server, they're getting to files or something like that. So this one would just stop all of the traffic in addition to, and then the more specific before the more general on down the line, and then after that the permit IP any, so that the implicit deny all doesn't take over for us. Let me get this one out of the way. We're going to come back to this guy a couple of times today as we go through the automation. I'm trying to do some demos. And again, I said the one of the Cisco machines that's usually available appears to be offline right now for one of the labs, but the other one, kind of its counterpart, is there. I hadn't tried configuring it before, so we'll see if that happens to, if it allows that. It may or may not when we get there. But automation and programmability, automation and configuration management, the topics here: planes and APIs, application programming interfaces, and then intent-based networking. Intent-based networking is kind of where we're going to with the iOSs that are in the bottom here. iOS XE is what would be used for the intent-based on down the line. When I couldn't get to the other one, we're going to have some non-intent basing, but it's going to be more like the software-defined access or software-defined networking that we had before intent-based. And then we'll make a swap because one of them I got to do local and one of them we got to do online. But the different operating systems that would be used in the different areas, the campus and the branch office is going to be the iOS XE. The management, the Cisco DNA Center, we'll take a look at that. I'm going to have a couple of videos today, Kevin Wallace videos, that I think do a reasonable job of these things. The data center, the NX OS, service providers, the iOS XR, and then security is going to be Firepower is the devices that we're going to use. The ecosystem here: Ansible, Puppet, and Chef. And Chef doesn't show up here. Terraform does. It's another one. But Ansible, Puppet, and Chef are explicit objectives that you need to know about, not know how to configure, although I'm going to try to show you Ansible to maybe make that a little more reasonable. But automation and configuration management is going to be the first topic here. And this is Cisco, and there's nothing magic about it. What is automation? The process of automating the configuring, managing, testing, deploying, and operating of physical and virtual devices within a network. With everyday network tasks and functions automated, and repetitive tasks, repetitive processes controlled and managed automatically, network service availability improves. What we want to do with automation is to allow automation to do the repetitive work. The wireless LAN controller, what did we want the wireless LAN controller to do? The repetitive work, where it creates the SSIDs, however many we have, on however many devices. It creates the SSIDs 10 times, 20 times, 30 times, 300 times, depending on what we have, so that we have to go to the 300 resources and type SSID, my network, or whatever we're using for those things. Any type of network can use network automation. We can go back to, and old devices can use that Python scripts, and I'll try to show you a couple of those without going around and kind of driving into the ground what we do. But you can automate from older iOSs up to these intent-based, these new iOS XE, which have specific APIs. They have specific hooks that allow specific actions to take place with them. So why automate? The growth of IT and the cost of network operations. And when we talk about costs, some of these things are going to be really expensive. We're going to talk about the DNA center, and I'll probably say it again. We're talking about 50, 70, 80, $150,000 for it. So mom and pop network probably not going to use that. But you can write a script, you can write a Python script and be able to manage these things. You can write an Ansible, as long as we can get to Ansible to be able to configure these things. A YAML script that goes with Ansible is what we'll use for those. We'll introduce the terms and then kind of look at what they are as we go through. But automation here, one of the many things that a lot of these CCIEs that are on giving advice talk about doing is that you young guys, one of the best things that you can do for yourself right now is do a Python course, a scripting course. And Python seems to be the most highly used one with these things. So a scripting course, probably worthwhile if you don't already know how to use Python. And there is a lot of those available for pay and for free around the system. So automation is something that everybody wants to do. And back to the cost, yeah, you got a cost for the automation, for the tools that you're going to use, but you got a one-time cost. Automation is something that allows the company to pay once instead of paying every 2 weeks, where they're going to pay the users to do that. And I know we've gone on from I was looking at Brian's. He's got a note in there about released a 4-hour instructional. It's free to acquire, like Java. Yeah. And there are a number of free ones. If you look on YouTube, David Bombal, I think, has one. He's got one at GNS3 also, which is not very expensive. His courses are pretty inexpensive. And Udemy's got a number of those. I bought one there, and it didn't really do for me what I wanted. I wanted one that helped me out with this stuff, and they wanted one that went into all of the other things that you can do. Anyhow, what we're trying to do with automation, and what you guys are learning how to do, is being the individuals who can do the automation, reducing the need for human interaction to perform tasks. Network automation reduce the need for human interaction to configure, manage, deploy, test, all of those things that were in the little Cisco thing here. When I was at the university in Roanoke, Advanced Auto's headquarters was there for a while, and that's where they started, and they moved some of it here and some of it there, but the data center stayed in Roanoke. So we had a lot of students that worked there. And when you're talking about, let's talk about upgrading or changing or managing or changing the software at the stores. I mean, how many stores? Tens of thousands of stores that are available. So this was all done with automation, with scripting. They had to write a script to do the updates. Also got to write a script to undo the updating in case something happens, or a rollback script had to be available for those things. And they usually were pretty successful, but I remember one time they weren't so successful. I went into one of the stores to buy something, and it's like, we can't sell you anything because the workstations are down. The point of sale terminals are down because they did an update and it didn't work. And if you do an update and it doesn't work in a company like that, you shut down thousands and thousands and thousands of stores that can't sell items, which is going to really impact profitability, obviously. Thousands of tasks are performed automatically on a regular basis. We see that happen, and just some really basic examples is when we go to daylight savings time, your computer automatically resets because of the time server. So the automation takes place there. A lot of things about Windows updates, they're going to happen automatically if you've configured them that way. Key ingredient in the cloud-based solutions, and that's where we're talking about part of the DevOps initiative. And in DevOps, here in the notes, DevOps is a set of practices that combines software development, dev, and information technology operations, ops, which aims to shorten the system's development life cycle and provide continuous delivery. Cisco do have a DevOps test, and there are DevOps classes that are available. So DevOps, if you're really interested in the automation, DevOps is the area of Cisco that you want to go to. And this is 1,000 devices to configure. How you're going to do it? Automation, or what we've been doing, command line interface. What we've been doing, command line interface, back to the advanced auto example, they're never going to be able to make the changes because thousands and thousands and thousands of stores, not just in the US, they've got them in other countries now, in the Caribbean, all sorts of places. I guess that you, if you were doing the ones in the Caribbean, would be good because you get a little vacation. Automation and network management, and some of the things that I want to try to show this, what can we do? Discover the changes in topology. Well, we've already seen that happen. That's what the dynamic routing protocols did. But this is going to happen on a larger scale. We're going to centralize eventually with the controller, and the controller is going to have an overarching view of the network, and it'll be able to see all of the elements that goes on. So, hey, the controller can now calculate the DNA center when we get there. It can now calculate the best path for all these things. It can see the cost. It can see where the delays are, all of the other things that are capable through the application programming interfaces to be able to do those things. Update and installing routes. Well, we did that, but we did that one device at a time. Updated did the calculation. Each individual router did the calculation. When we go to automation, we're going to have a centralized calculation for these things. Discovering routes, providing the best paths, managing bandwidth, updating software, implementing security and compliance, setting performance benchmarks, and then performing root cause analysis of network issues. All things that we can do, will do, or have the capability to do with automation. Benefits, we're always going to say lower cost, because if you don't say lower cost, then nobody's going to buy it, because lower cost, but there's going to be an implementation cost for all of these things. Increased business activity, productivity, and then increased business agility are the things that are going to be here. Some of the devices, I guess, that are available for this: Puppet, Chef, and Ansible, and these are the three that are the explicit objectives of the CCNA. Puppet, open source software configuration management tool, SCM, software configuration management tool used for deploying, configuring, and managing servers. Cloud deployments, uses a master-slave architecture. All of these, the two top ones, Puppet and Chef, have to have an agent on the device. Ansible does not have to have an agent. That's one of the reasons that's where I'm going to try to do the demo with it. Used in cloud deployments, universal specifications. Chef, an automation tool based on Ruby. You don't have to know how to program in Ruby. You just need to know that it's based on Ruby. recipes to record and update the information when we do these things. Ansible is going to use playbooks. We're going to have a couple of slides later on that'll what do they use, what's the terminology that's used for these things. Simple open source IT automation platform, commonly used for websites and documentation, uses a push-based architecture. The other two use a push-pull. Push-pull, the device that has the agent running on it pulls the configuration from the component here, the Puppet or the shelf that goes on with these things. But Ansible uses a push. It does not need an agent on the individual devices. It runs over SSH, can be stored anywhere. No servers or databases are needed for it. Before we go for the rest of the slides, and then we'll go one order, doesn't really matter what order, I want to do a little video here. Let me get the ad out of the way. Well, the ad is out of the way. So let me drag this over here. This is a Kevin Wallace. I'm a couple of Kevin Wallace videos that I want to try to do. And let me configure this. I'm going to turn on my computer audio if I can find that share sound. I'm going to turn me off. So while we watch this little one overview about Puppet, Chef, and Ansible, Puppet, and Chef.
Hey, welcome back to the channel, everybody. This is Kevin, and in this week's video, we're going to take a look at a topic from the CCNA exam blueprint. That's exam 200-301. Specifically, we're going to be talking about 3 configuration management tools: Puppet and Chef and Ansible. And if you look at that exam blueprint, it tells us we don't have to be able to configure or troubleshoot or really even thoroughly explain these. It says we have to be able to recognize the capabilities of these tools. And that's what we're going to do in this video, which is taken from our CCNA video training series. And as always, if you enjoyed the video, please give me a like down below and subscribe so you don't miss any of our weekly content. In our previous video, when we were talking about the DevOps lifecycle, we said in the deploy phase, we were pushing configurations out to our devices, and we wanted to maintain consistency in our configuration across the devices, and we wanted to have scalability. We didn't want to have to go to each device and one at a time do a configuration. And we said that for the exam, Cisco wanted us to know about 3 specific configuration management tools, and those were Puppet, Chef, and Ansible. We're going to consider those in this video at a high level. Specifically on the Cisco exam blueprint, they tell us that they just want us to be able to recognize the capabilities of these tools. We don't have to configure them. We don't need to know how to write the configuration code that these tools are going to use. We just need to recognize what they can do for us. And they all have the basic same purpose in life. They're going to be able to push configuration changes from some sort of a file that we have out to our managed devices like routers or switches. And specifically, we're going to be focused on Cisco Nexus switches. Those are switches that we typically see in a data center environment. And the reason we're really going to be focused on those is 2 of these tools, Puppet and Chef, they're going to require that something be installed. An agent has to be installed on the devices that we're managing. And since Cisco Nexus allows us to install software because it essentially has a layer in the software that's running Linux, and we can install things on top of that Linux platform, we're going to be able to install that agent. And that's as opposed to our traditional Cisco iOS devices like our ISR routers, our Cisco Catalyst switches. But we'll see that Ansible does not require an agent. We can just push instructions one way. And let's dive into these just a bit more, beginning with Puppet. Puppet is written in Ruby, and when people hear that, they often think they have to be expert programmers in Ruby in order to use Puppet. That's really not the case. We just have to get comfortable with the configuration file structure, and I'll give you a simple snippet here in just a few moments. But we don't have to be expert Ruby programmers, so don't let that throw you off. And within Puppet, we're going to declare different resources and say what type of resource it is. There's a couple of examples. A resource might be an interface that we're going to configure. A resource might be an OSPF process that we're going to run. And the parameters or the characteristics that we want to assign to that resource is done with a class. A class is a set of common configuration settings. For example, a setting for an interface resource might be an IP address for that interface. And then we can take a collection of those common configuration settings and group them together in what's called a manifest. This is the Puppet code. This is what gets sent out to our devices. This manifest is going to accomplish a particular job, and it's going to contain a collection of classes. And we probably have more than one manifest to do different jobs, and we can store those in a repository called a module. And in order for this to work, we need to install a Puppet server on a server, and we have to install Puppet agents on the devices that we're going to be managing. And we'll need to do that to our Cisco Nexus switches as an example. And what we can do is say, I want these switches to be in a particular state. I want them to have a specific configuration, in other words. And we can represent our intent for what state we want them to be in one of those manifest documents. That set of Puppet instructions. And let's just say that the state we are after, we're just calling state B. And again, we don't need to worry about the syntax for the exam, but just to give you a simple example of what the configuration file might look like, even though we're not Ruby experts, I think we can read this pretty well. We see that we're configuring interface Ethernet 1/4. We see that it's currently shut down because shutdown is set to true. Switch port mode is disabled. In other words, it's set as a routed port. It's being managed by Puppet. That's our description. And we see that the IP address is 172.16.1.24, and we're not applying this specific configuration file to these switches in this example. We don't want to assign the same IP addresses to all of our switches. I just wanted to give you an example of the syntax that we might find inside of one of these manifests. But let's say that we've got this big manifest with all kinds of instructions, and it represents the state we want our devices to be in, and we're just calling it state B as an example. And we can have bidirectional communication between the server and the agents that are running on these Nexus switches. And we can check to see what their states are. And maybe the top and bottom switches, they're in state A. They're in a different state than what we want. The middle switch, it's in state B, so we don't need to do any configuration there. But what we can do is we can push out this manifest and make changes on those top and bottom switches so that they become compliant with the state we want everybody to be in. That's an example of what Puppet can do for us. Chef is very similar. Chef is also written in Ruby. The terminology we use is a little bit different. Since we're using the metaphor of being a chef and cooking, we say that our configuration instructions are contained in recipes. And a recipe is going to be configuration instructions for a specific task, like creating a .1Q trunk, for example. And we can have a collection of recipes to go into, can you guess? Yeah, a cookbook. We're going to put those in a cookbook. That's a collection of recipes. And there actually is a cookbook that's called the Cisco Cookbook, and we can install that on our Chef server. And just like Puppet, we need to have an agent on these Nexus switches. We're going to install a Chef client that's going to be our agent that we put on these switches. Now we can have bidirectional communication. And even though we don't have to do coding or interpret code on the exam, here's a sample of what a configuration might look like. Again, I think we can interpret this without being Ruby experts. In the top example, we're going into Ethernet 1/1, and it looks like we have an IP address of 192.168.1.1 with a /24 subnet mask. We're bringing it up administratively because shutdown is set to false. Switch port mode is disabled, meaning this is a routed port. And then we've got Ethernet 1/2. We're bringing it up administratively. Its switch port mode is access. So this is not a routed port. This is an actual switch port, and we're assigning it to VLAN 200. That's just a simple example of the kind of code that we might find in the instructions that we're pushing out to our devices. Now, the third example is Ansible. And this is the one that really stands apart from the other two. The other two used a server and agents on the managed devices. This is going to be an agentless model. And again, the terminology is a bit different. We're going to have what's called a playbook. That's going to be our configuration instructions. And the configuration instructions are written in a language called YAML, Y-A-M-L. And when I first saw that, my guess was that that stood for yet another markup language. But And I've double checked this with many, many resources because it just seems wrong, but this is actually from the official site. This is what YAML stands for. It stands for YAML Ain't Markup Language. That doesn't seem grammatically correct to me. Does that bother anybody? It bothers me, but I'll try to ignore it and move on. But YAML, that's how we're going to write our configuration instructions using that command syntax. And then we're going to have an inventory. That's a list of devices that we're going to apply our configuration to. What we're going to do is take that playbook and run it against our inventory. And again, the big distinction between Ansible and the other two tools we talked about, Puppet and Chef, no agent is going to be required. Now let's take a look at what this YAML configuration might look like. And this is just a simple example. This is not an example we would be applying to these Cisco Nexus switches. But here, I think it's pretty readable. We see that we're applying a description of engineering interface and an IP address of 10.5.5.1 with an IP address of 255.255.255.192. We're applying that to a parent interface of interface gigabit Ethernet 1. And we're applying an IP helper address of 10.1.1.100 to a couple of parent items. Those items are interfaces gigabit Ethernet 1 and gigabit Ethernet 2. And as a review, here's the Ansible process. We've got a playbook with a set of configuration instructions. We've got an inventory, which is a list of devices. And we're going to run that playbook against that inventory, and our server, or just basic machine, it doesn't have to be a high-powered server again, it's going to send those configuration instructions using Secure Shell one way out to our managed devices, and it's going to be applied on those devices. No agent required. That's what I want you to know for the exam about Puppet, Chef, and Ansible. As you start getting more into these in the real world, you'll see that there are some exceptions to what we just discussed. For example, there is such a thing as agentless Puppet. There is an option to do what's called a chef push, where we can push instructions out to a device that's not managed by an agent. We could use Puppet, for example, with traditional Cisco iOS devices by having a Puppet proxy. So there are lots of different things that we can do beyond what we've talked about here. But this is the high-level overview that I want you to know for the exam. Again, to summarize, we've talked about 3 configuration management tools. The goals being we want scalability and we want consistency in our configuration, and we want the ability to do quick deployments. 2 of those tools, Puppet and Chef, required that we had agents installed on the managed devices. And we said those are going to be typically Cisco Nexus switches because they are actually running Linux, and we can install the agents on top of that Linux platform running inside of our Cisco Nexus switches. And we said we could alternately use Ansible. Ansible is going to be able to push configuration changes using Secure Shell out to devices without those devices having to have an agent installed. And that's a look at our 3 configuration management tools that we need to know for this exam.
The agents required for Chef and Puppet, Matthew. The Ansible doesn't need one. So depends on what you're using. And I think also one of the things, the agent, you got to have an iOS that will support it. And we're getting into the Linux world. The device would not be able to report back to them as when bad stuff happens. If you use Ansible, it doesn't have an agent for that. I don't know if that helps any or not. And back to Clay, the reason he talks funny, he's from Kentucky. He's from Southeast Kentucky. He's in Richmond, Kentucky, actually, which is on the edge of, actually, is in Appalachia. So yeah, he talks funny. And I used to talk the same way because he's from not very far from where I was born when we do that. No, it's just the way that people there talk from that. I've lost some of it, but not all of it. When I go back, my wife accuses me of reverting. So I don't know if is there a reason to not have an agent. The reason that we would not have an agent is, back to Matthews, depends on what the equipment is that we're working on. I want to go through a couple of slides, and I want to try to show you the agentless Ansible in an old form. A little bit later, we're going to get into intent-based, and I'm going to try to do the intent-based. That's the one that I need the Cisco device that I think that I might be able to access or not be able to access to do the intent-based for those. So again, what equipment we have, as well as what capabilities, what we bought. Some of these things are free, some not so free. To check before pushing to the switches, no. For Ansible, no, you just push it. No, you'll just push it out. It will, if the configuration's already there, it won't matter. And you got to be sure that you're sending the configurations that you want. So does it check? No, it just pushes it out. Here we go with these things. The other two, Puppet and Chef, a little bit more sophisticated, but Puppet and Chef also going to require a little bit more sophisticated equipment in order for them to work also. Yeah, I would just overwrite the current config. And that's the same config, exactly what Matthew said. That's all it would do, is just do that. Do what's going on. So some terms here, orchestration, and probably, this is one of those, yeah, I've been there, done that. You probably got this. Arranging automated tasks in a logical and coordinated fashion. How are we going to prevent some of the things that you guys are talking about here? The configuration management tool, Ansible, Chef, Puppet, SaltStack. SaltStack is another one that gets thrown in there. It's not on the objectives. If you do CCNP, they add it for that. Different ones here. Ansible, the kind of, well, maybe we'll call it basic, but Ansible is installed on a Mac or a Linux machine, uses playbooks, and plays are in playbooks. Kind of maybe your football guys, you had a playbook and you have plays, or basketball, you have plays and playbooks. You have plays and you put them in the playbook and you study the playbook. So we're going to have this. Inventory, the files provide the device host names along with the information about the device, like their roles, so it can perform the functions for the subsets of the inventory. Templates, and we'll talk about templates a little bit. Templates use the Jinja 2 language, and this is not something that is part of, it's just something to know about if you start using these things. So what we're eventually going to get to is we can go out and get information, and we've got templates, and we take the information that we discern from the devices using the APIs, put them maybe in a database file of some sort. It doesn't have to be like an SQL database, but some sort of a database document. And then we can use the templates with the processing in order to do some of the automation for this. The variables here are going to use the YAML language for that. It uses SSH. TCP port 22 is agentless, uses SSH and netconf. Netconf, and as we move on up, we're going to use this thing called RESTconf, representational state transfer configuration. This is just network configuration. Older devices will support netconf, but not RESTconf when we do these things. So the Ansible push model, we have the inventory, the templates, and the variables, and I want to try to look at each of these documents. Yeah, maybe we'll see where we are, maybe before we do the break, maybe right after the break. So we take these, we run the playbook, and then push the configuration over SSH to the device. And yeah, this is one of those that there's not going to be any two-way conversation with them. So Ansible, inventory, API, modules, and plugins are all going to be part of the Ansible engine. Public-private cloud, however we're using these things, the user is going to create the playbook, go through the Ansible engine configuration to the hosts, whether it's local or remote. And a lot of the automation was done with the cloud in mind. So the Ansible management here, we have the inventory, and the inventory is going to be a host file. The inventory is going to be the devices that we're going to work on. And in the inventory, well, we'll look at an inventory and a host file. we can group machines together in order to activate or work on them simultaneously when you do things. So we can have a playbook. Playbook consists of plays. Go to the Ansible management node, the device, the Linux machine, the one I have, a little Linux virtual machine. And then through SSH, the controlling machine is going to send the configurations to the individual devices when we do that. Chef, the resource configuration objects whose state is managed by Chef, a set of configuration commands for a network device, ingredients in a recipe or a cookbook. So we're going to have recipes and cookbooks that go with Chef for it. It runs on HTTPS TCP port 443. So Chef, we have to have an agent. It's not agentless. Run list, the ordered list of recipes that will be run against a given device. So just like if you were cooking, we have recipes, and a bunch of recipes go into a cookbook for this thing. Here they got the policy here, the server, we got the chef server, and then we have to have the agents on the devices, which means that we have to have devices that will support the agents. The iOSs that are going to be used are going to be significant with these things. Puppet, installed on a Linux host, uses a manifest, a human readable text file on the Puppet master, using a language defined by Puppet, used to define the desired configuration state of the device, the desired configuration state, intent-based networking. What do we intend for it to be? Resource class, we have modules, refer to the components of the manifest for these things. Templates, uses the Puppet domain-specific language, allow Puppet to generate manifest modules, classes, and resources by substituting the variables into a template. It is also agent-based, uses HTTPS, but it uses a non-standard port, 8140. And this, not every Cisco device supports Puppet, not every Cisco device supports Chef. You've got to be able to install the agent on the device. So templates, variables, the manifest, pull details, pull config, the pull, the start the agent. So here we build the files, start the agent, pull the details, and then pull the config from the manifest from the device. It can be, and again, each of these can be configured as push devices also. Just kind of around the world, define your desired state. Your desired state, again, intent-based networking, desired state, what I want it to be. I want it to be on, or I want it to be off. And then simulate the configuration, enforce the configuration, and then it's going to report back. So the two-way, the agent, as well as the controlling device, the agent on the devices, the Cisco devices, make it a two-way communication. Salt stack, another one that you don't have to really know about. Request is initiated here. The salt stack tables, the commands, the runners, the minions. Minions, I love that. File state, and then events for these things. The status, let's see, the status is going to be pending here in the status. The results after we go back 1, 2, the pending status, we send it to the device. The service now is called a reactor. The salt stack master sends the command to the devices. Here, 5, the salt stack minions execute the command. And then 6, the results are returned, which is yes, it was successful, or no, it was not successful. A little summary here for the terms, and these are probably for the CCNA, something that's a little more significant. The Ansible's playbooks uses SSH secure shell, and it uses the standard port 21. Agentless uses a push model. Puppet uses a manifest. HTTP REST is representational state transfer. The agent is required on it. It is a pull model, as is Chef. Recipes and run list, HTTP REST agent pull that goes on with it. And another little, yeah, this is the way we go. The architecture for Puppet, Chef, Ansible, and again, SaltStack's not part of the objectives. It's just on this particular table. Architecture for Puppet masters and agents. The language is Ruby. The tool output modules and manifest has an agentless version, Puppet Bolt. The device management is going to be the Puppet master, and Chef's going to be the Chef master. It's a server and clients. It's going to be Ruby. Cookbooks and recipes does not have an agentless version. Ansible is an agentless version. It's got a control station. Remote hosts and its language is going to be YAML. Playbooks and plays. We got a yes here for the agentless version because it is agentless, and this device management, any device. It's something that you can download, and when I put it on the Linux machine, it's just a matter of say, okay, install it. It installed it. It went very, very smoothly for that. SaltStack, the Salt Master, it uses Python, pillars and grains. Agentless is Salt SSH, and then we have the device management is the Salt Master. I think that we'll go ahead and take a break, and let me get set up on the break and see if I can do a little demo of Ansible, what we're really talking about. What are these plays, playbooks, and the how do we control which of the devices? I'll go there. Questions, comments? Before we go on to the data formats, and you will need to know particularly the JSON data format, take a quick look here at Ansible, and I think that it did it to me again, or I did it to me again. Let me see if I can do a little better job here with the arrangement of this thing. You think that after a while it'd figure out that this is what I want, wouldn't you? So this is my Linux machine where it's installed. Well, let's go back and look. I'm running on GNS3, this topology. This goes into a local cloud, so my Linux machine is connected to it. I've got some very, 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 very basic, and we're going to do a very, very, very basic look at it. I don't know if I had another one. I don't think I had another one there. Yeah, make this a little bigger so you can see it. There's not a there's like a nothing. It's got an IP address running on this. So we're going to make a very basic configuration change, and I've got one, and I've been trying to go through. YAML has just kind of driven me a little bit nutty when I do this thing. So if you show an IP interface brief, and I think what we'll do is let's put a loopback interface. So it's got an IP address 192.168.60.6, and that's the network that it's on, is the 192.168.60 network for that. So let's go back to this guy, and let me make it a little bigger here. This is the Ansible folder, and if I do a dir or an ls, either one should work on here. We've got an access control list, YAML, DevNet, some of the things I've been fooling around with trying to make, and this one's going to be loop back, but down here we have this hosts file, and there should be a config file in here. If you do this, and Ansible config, if you would do this unwritable, because I didn't do a sudo here, the configs that go into it, you can basically leave everything until you get down about halfway. I won't tell you this just in case you want to do this, until you get host key checking false. What this does is checks to be sure. Cisco tends to not use trusted certificates. They tend to do their own signing. So what this says is don't check don't check the Cisco guys. So we're going to have a configuration file. We're also going to have a host file with the inventory that it talked about. And this would be the inventory. And I got a couple of inventories in this one down here. We got this one routers. These are the ones that go on the internet. These are the ones we're going to try a little bit later, see if they will actually connect for the intent base, because they are iOS XE devices. We can go on down here, and I have some GNS3 configured here. Ansible demo is the grouping that I have for these guys. And the other information up here, the routers, the variables that go on Ansible user, and then the password that goes along with it. The connection here, we're going to use the command line interface. The network OS is going to be the iOS, and then the port, because the Cisco one uses a non-standard port. It uses port 8181. The GNS3s that I have down here, the usable, and then the password, the Ansible password, the different ones. OSPF, R5, R6, and R7. The devices that we would have in here for OSPF. I'm not going to go there, but just when we're talking about inventory, we have to create our inventory. Let's see, get out of here. The other thing, and I think what we want to do is here is just, I'm going to just do the loopback, and I think loopback 1 is the one that works. Again, I save them, and then I make them go away, and I save them, and one of these works and one of these doesn't work. And maybe this is the one that does work. So the name here, this is what a YAML file looks like. The YAML file, spacing makes a difference here. So the name here is going to be the play, and this is going to be a playbook. So this is going to be a play. The name add loopback playbook, and the host here, I'm just going to use R6. The host file, I'm going to use R6 out of it. And the host file R6 is in here. Create a host file that's associated with its IP address to do these things. Gather facts, connection, the variables, the command line interface, username and password, the tasks that we're going to be name, add a loopback interface, iOS config, provider here is going to be command line interface, authorized, yes, and authorized is the authority to make changes in this thing. Authorized password. Parents, just kind of the context. The parents is interface loopback 61, and then we're going to assign it an IP address of 10.10.61.1. Nothing really dramatic here. Is just that what we see. We're going to say Ansible, I think, ANSI, Ansible dash playbook, and the playbook that we're going to use is loopback.yaml, and with any, it says it pay the play, the add the loopback playbook, the task add a loopback interface. So it comes back and says, okay, changed 1, and it kind of goes back to, yeah, it doesn't check that I think that Jamal asked, but it tells us whether it actually made the change or not, or at least attempted the change or not. And we'll go back to this interface, and it looks like maybe we had some things going on here. Configured from console by Larry on VTY 0, 192, and 68, the IP address of the other guy. So we can do in here, show an IP interface brief now, and sure enough, we have the loopback 61, 10.10.61.1. I was trying to, and maybe the OSPF one will work. I don't remember if it does or not. It may blow up. But if I do a dir here, what if we wanted to put OSPF on all of these devices? And let me see. And I said, I don't remember when I was playing with this thing if it actually did anything or not. But it says to manage the GNS3 devices. This will be all of them, the host OSPF, the hosts that were in that manage GNS that we saw in the reference there. So we're going to look at all of those devices, and network 0.0.0. Let's see if Well, actually, I guess that we could see if it blows up to see if it will work, kind of give you an idea of being able to maybe do multiples at the same time. Yeah, playbook, and it's going to be OSPF.YAML, the task to enable these things. And again, we'll see. We'll see. It may or may not. So it says, yeah, it changed all of those. Could you go and install OSPF and all these guys at the same time? Router OSPF1 and the network's going to advertise any network, the 0.0.0.0 network. So we can just look at one of these and let's do a show IP protocols here. And OSPF1 is installed on this with the advertising all of the networks. So show IP routing. I don't think there are any other networks on any of the other devices, but it installed OSPF on this one and should have installed OSPF on all of the other ones. I guess we can go at R5 here and see if it is there. Hey, yeah, it is, because we just process one is loading to full and it's done loading. So OSPF, bingo, we've installed it on all of those routers simultaneously. So repetitive tasks, similar tasks, the network, what you're going to advertise kind of gets in, and that's why they advertise everything on this one. Worked for me on that one. There aren't any others, so that doesn't really do a whole lot of anything. It appears here, except starts it up. So now if we add networks, it will advertise those to the others. So the show IP protocols for this one, OSPF1, routing for networks, area 0, all of the things that we would expect to happen are going there with that one. So again, kind of a, I guess, rudimentary look, but a kind of a basic look at what we're talking about with Ansible and with automation. And yeah, you can get Ansible pretty readily, and GNS3, yeah, you can get it. It's free also. The iOS has become the issue. You got to provide your own iOSs, and the people that provide GNS3 can't do that for you. The data formats that are used, we'll start out here with Java, JavaScript, and JSON. JavaScript, not really what we're going to use here. Lightweight scripting language for dynamic content interoperability on web pages. When we have motion activity on a web page, frequently that's going to be JavaScript that does that. Works with HTML and CSS. HTML, the protocol that we use in order to get the web pages. CSS is the configuration, so it's going to be used in a lot of pages. The one that you need to know about, and you do need to know the format of this one, I'm going to have some slides on what the formats look like. JSON is an open standard text-based data format. Human and machine readable, used to transmit data objects and arrays on the web. We're going to use HTTPS, and we're going to use instead of a URL, we're going to call it a URI, Universal Resource Identifier. And I think way back when we used to call it URIs before we called them URL, the links here, but we're going to use this protocol to find the objects on the devices. And we've talked about objects that we use in order to do configuration. We had the object identifier, the OID with SNMP, similar concept here for these things. Low overhead alternative to XML, used to exchange data in web services, and it contains a name value pairs, and that's the thing that you need to be able to distinguish if asked for certification purposes, based on the JavaScript syntax and used in a number of programming languages. Here the open JSON files you can import them. We can use Notepad, or we can put them into an Excel or JSON viewer. The differences between JSON and XML: JSON is text-based, XML is a markup language. JSON can define anything. XML has some rules. JSON, similar to JavaScript, browses and reads faster, and the browser needs parsers to handle the XML. Can be slow in processing, no support on the namespace and the comments, and both are supported in XML. So lightweight, easily readable, relatively easily readable anyway, quicker language is going to be used for the things that we have. The XML, and this is unreadable, I think, but what I want to show is XML and what we would use with, we've talked about the language XML here. This is for that website, the dog club, and this is the ID here. This is, we're going to look at the page. This is the data that supports a template that I'll show you in a second to create a web page that has all of the winners of the English Setter Association of America's Nationals back to, I think, 1922. ID here, 2019, there wasn't a 2020 show, so 2019 is going to be the last one. The winners and all of the information that's going to go into this page that we'll look at here in just a second to get these things. The best of winners, best of breed, best of opposite sex, winner's dog, winner's bitch, futurity, best of opposite sex, maturity, maturity here that we have, some other information, where it was, the judges, and then a photo that's going to be put into all of these things. And the photo, the height and the width, the definition of the size of the photo that's going to be in here. So the information that goes into the web page, that's going to be here. Rules have to be followed up here, where the definition is going to be for the schema that goes into this particular XML. Let me find it here. I just opened it. Maybe I didn't just open it. Can't believe I probably opened it and then closed it. Here it is. The template that goes along with this thing, an XML template, is going to go get that information, the location, the judges, the best of breed, and all of those other things that were in the definition that was there for these particular ones. So then when we go to the web, let me get some of this stuff out of here. When we go to the web, and this is the ESAA website, and we'll go down here to, I think it's library and gallery, history section, past national winners. And you notice that it did take a second or two to actually read the data, but the information that we had, the years and the winners and all the things down one to the other. What makes this accordion here is going to be Java. So Java is part of this as well as XML. It goes all the way down. You could go look at any given year and find out the information if you cared about this kind of stuff, who won, who was there, who judged, those sorts of things. So XML is a structured language. It has rules, and you saw that it had a definition for the XML that went along with it. But the other, maybe the other XML document, a little more readable than this one when we do these things, used for encoding, and the data formats, both human readable and machine readable. Probably more of a machine readable than human readable. It kind of a pain to try to write when we do these things. YAML, human friendly. You got to learn the rules of YAML. It says it's human friendly, and I guess it's getting more friendly with me. When I try to start writing it, it's like, okay, I have had dozens and dozens and dozens of errors when we do this thing. Spacing becomes really important in YAML. human standard for all programming languages here. The zone configuration and entry is going to be the comment zone, and then the name red apple. So the zone and then spacing underneath it. And I think you have to have at least 2 or 3 spaces before it will recognize. I don't remember exactly what it was, but we have the zone. Oh, you went too far. Zone map, sun, different elements that are going to go into this YAML file. The one that you really want to focus on here is JSON. JavaScript object notation, I think is what it stands for. The objects, we're going to have key value pairs. The object's a series of key colon values, key colon value, key colon value. So key and then a colon and then the value. The key is always going to be in double quotes. The value format depends upon the type, whether it's in quotes or not. The different key value pairs are going to be comma separated. And the format of this is something that you probably want to take along with you. The object begins and ends with curly braces. So we're going to have objects here, curly braces. I'm going to try to put all these together with some images here in just a second, examples in just a second. The values, whether they're in quotes or not, string values, characters, text inside of them are in double quotes. Numbers, numerals are without quotes. Arrays are going to be in square brackets and objects are going to be in curly brackets. Arrays is just a list. So an array is going to be in square brackets. Objects are going to be in curly brackets. And all of these things are going to be defined with key value pairs that go along with them. So a JSON example here, a sample array list, square brackets. The array here, Dallas, Houston, San Antonio is going to be the array. This one is only the values separated by commas. And when we say separated by commas, we go down here, separated by commas, each of these until we get to the last one. It doesn't have, the last one's not going to have a comma because there's nothing that follows it except the closing of the array. JSON here, the object are going to start with the curly bracket. So we have an object here, and we can have objects within objects is what this one is showing. We have an object here, first name, key, value, double quotes for the key, colon, and then character string is going to be in double quotes. Last name, and then the address, an object within the object, and that's okay. Double quotes, key, value pairs, colon separates them. This number is treated as a text string and not as a numeral. The numeral are things that we can do arithmetic on. So you might, depending on how you're going to use it, would be the way that you would create the value pair for these things. So we have these things, comma separating it, the address here, and then within the address, the object, the comma, till we get to the last one, the zip code here, no comma after that. But object begins, object ends, a comma is going to separate these things from the next entry in this particular object. And we get down here and then we have the email, and then we're going to close the object. So it starts and ends, the objects start and end with curly braces to distinguish them. Some other things, a JSON object here with 2 key value pairs, and these are taken from Wendell Odom's book. We have an object here, favorite players, and then we're going to have a listing here, an array that goes on. An array again is just a list, but within the array we have the key here, the favorite players, and then the data, the key value. We're going to have 3 values that go with this particular key, separated by commas until we get to the last one. No comma here, but after the array we have the comma, favorite players, the next key value, and then favorite teams. Same sort of arrangement. Open the object, close the object. no comma after the last entry in the array, no comma after the last entry in the object. We have a comma after the first entry in the object that we have for these things. Again, the format of these are what you really need to know. JSON object with two keys and the values here. We have in here, Windows favorites here. We have the player, the object, player, Messi, Team Barcelona, League, La Liga here in the format. Windows favorites, the object key value pairs that go into these things. We've got a comma here, go on to the next one. The interface configuration. So we're going to have the interface configurations here is going to be the key, and then the configs, we know that we have more than one thing in an interface configuration. So it's going to be an object here, the IP address, the IP mask, and the speed, all things that can be configured. Objects open and closed with the curly braces. Commas separate what goes on, nothing at the last one because nothing follows it. If something follows it, you need a comma. The last one's not going to have a comma associated with it. One more, actually a couple more slides for this one, but the JSON object here, the roll number, and this number, this digit is treated as a number. We could do arithmetic on it. So the roll number, the double quote, the colon, the first name, colon, on down the line. You can have booleans in here also. Boolean false, permanent false, or permanent true. Boolean true or false for these things, 0, yes or no. But we have comma, comma, comma. We have the address here. The address is going to be an object. The key value pairs that go along with it. Comma because more follows after this object, where you open and close it with the curly braces. Phone numbers, more than one. An array with the square brackets, comma between them, no comma at the end, more after the array, another array here, cities, Dallas, San Antonio, Irving. Properties, play, badminton, interest, math, age, 34 years. And then the last object, no comma. We have comma for all of these others, something follows. So the only thing that follows this one is going to be the closing brackets. Closing brackets, we have created an object here. The student is going to be the object, the definition of the properties that go along with a student. The JSON examples, these are, I think, out of the BOSIN exam sim. So this is the kind of thing that you might see. Which of the following statements are true? Select two, and they will tell you how many to select. The value of the read-only is the value of the read-only key is a text value. Well, the read-only key is going to be an array, so that's not true. The value of the last name key is not a text value. Well, it is a text value. The value of the ID key is an array. Well, it's a number. It's a digit. The value of the first name is a text, and yes, that is true. The value of the group key is an object, and that's true because we have the group here. And the value of the roll key is an object. The roll key, again, is going to be another array. And I think maybe this is the last one of those in here. A REST API query returns the following output. Which of the following statements is true? And then the value of the last name is a text value. The others, if you look through that, are not going to be correct. But these are the kinds of things that you should be ready to face when you get to the CERT exam. The summary here: the keys are in double quotes, the strings are in double quotes, the numbers have no quotes. Lists, arrays are in square brackets, objects are in curly braces. And the goal of this thing is to be human readable, as well as machine readable, space tolerant, which means that spacing, unlike YAML, where spacing is significant, spacing is not going to be significant. You can use spacing to make it more readable with these things. This is, if you write a JSON, JSONcompare.com will tell you whether it's a valid JSON format if you want to use that. So the www.jsoncompare.com. Should you do these things? Yeah, did I do it right or didn't I do it right for those things? Templates, variables that go on, and we looked at a little bit in XML, templates and various similar devices, similar roles. The one that I did was similar devices, similar roles. So instead of, I didn't have a template, I'm not that clever to do that. Hopefully I'll get there, but not yet. But we could have taken maybe entries from the various ones. We had different networks that we wanted to advertise, or maybe different configurations that we wanted to do on the different interfaces of those devices. Put them in a data format. And as we went from one device to the other, we use this template, the template where we advertise the networks. Well, we're going to advertise different networks on the different devices. Maybe where we configure the interfaces. Well, we're going to have different IP addresses on the different interfaces. So we can do those configurations for those things. Same row configs are often very similar, which is what we had in the case that we use for these things. And this is an excerpt from a branch router. The highlighted fields may be the same in multiple routers, and we had the same in multiple routers. We use router OSPF1. We know that the process ID can be the same everywhere. So what's the big deal? So router OSPF1, enable the router. Network, we want to advertise all the devices. We can use the same in all of them. May be the same. The configuration management tools separate component configs into the common for all devices and then those that are unique for the other devices. So variables as well as some kind of a data structure. And it could just be a text file of some sort. Something like the hosts file that I had that's separated into different components that it's used. We use the OSPF to define those, and later on we're going to use the routers in order to try to get to the Cisco devices to go into these things. A template here, and template in the database that we would have here. Template, the host name BR1, the interface configuration interface gigabit 00. The IP address is going to go in the double curly braces here say this is a variable. So the address looks for address 1, and address 1 over here is going to be 10.1.1.1, the database that we're using for these things. Mask 1, 255.255.255.0, and this one I've got a mask 1 and a mask 2. We could just use a mask here because it's the same for all of them. IP OSPF, the OSPF process ID 1, and we can use it for both of them. The area here, area 11, we're going to use it for both of them. And then go to gig 00, same arrangement, same database, different information for the IP address. That needs to be different. But the process ID, hey, it doesn't matter. The area, we're advertising in the same area. And then a router ID, for this one, we're assigning it a router ID. We could have those and they have to be unique. So if we did this, we would need like RID 1, RID 2, RID 3 if we were going to assign a router ID for each of them. Only gig 02 down here, router OSPF, the second one is going to have a router ID, or the router OSPF is the only one that's going to have the RID in it. The tools that we're using here define the logic and the processes, what changes to make on the devices. Same thing we had before, the host, the templates, and the variables. What we saw, at least kind of, it didn't have a template, but what we saw in the Ansible demo, we had the host, what are we going to do? And then what are we going to change? The variables, the templates, the actions, and the programs. Eventually, we're going to be able to go someplace, get the information, put that information into a database, store the information someplace, and then process it, templates, then take that information and use it in the programming to increase the automation that's going to be available with our devices. Network programmability, the use of software and a network configuration to maintain these things. The APIC EM, and there is a video of the APIC EM, the one I couldn't think about yesterday, the Application Programming Infrastructure Controller Enterprise Module. That is kind of interesting viewing. It's another Kevin Wallace video that's available on that blog page to what is software-defined networking. And it's one, and he does, hey, I've got an access controller someplace in my infrastructure that causing a problem. Path trace tool allows you to send something across the network. It'll tell you where the problems are. So some automation that's going to happen with these things. Device level static configuration, not going to be required here. The device level, where what we've been doing and what CCNA is and always has been since I've been one, device level configuration. We go to one at a time, use the command line interface, type in the commands. What we're trying to do with programmability is make that more efficient so that you, the individual that's done the training and done the research and done the study and acquired the skills, can now not have to go to one device at a time. You're the one that's able to be who's left after. Yeah, we don't need all these people. We want to do automation. So what are we going to do? We want to get away from the device level. Uses APIs to enable the communication with the devices to gather data and set the configuration. Simplifies the network administration. Easier to modify the network infrastructure when we do these things. It's at least quicker to do that. Reduce configuration errors because we're not going to have the typos. And if we have the typos, it's going to be everywhere, and we can fix the typos very quickly also. Kind of like what you did in the wireless LAN controller. Yeah, we put that in and then bingo, it goes to all of those devices simultaneously. And as long as we get the configuration right once, we don't have those information. This was the software-defined networking. So software-defined networking, it's one of those, I think, kind of nebulous things. And it's like, what are they talking about? For me, what are they talking about? And here's what it is. And what are they talking about? And here's what it is. And we had the different elements that went into it. What we're talking about is using scripting, automation tools, programming through software in order to define the network structure, the network configurations that we're going to be using with these devices. Some of the things that are here that can be used, the Cisco APIC Enterprise Module. And in the notes here, let me get this over here where I can read the note. APIC EM software-defined networking controller for enterprise networks in the campus or branch and the WAN. End of life cycle was replaced by the Cisco DNA. And the Cisco DNA is going to be not that inexpensive. The SDN controller and OpenFlow commercial distribution of the open source Open Daylight software-defined networking software-defined networking controller, and then the application-centric infrastructure. This is going to be in the data center, the ACI. Is going to be used there. Just which approach is used in which of the areas. The traditional network architecture, we have the data plane involves the network devices, the routers, which route packets or messages using the forwarding table. The controller handles all the functions in the control plane, and the southbound interfaces. Southbound we have these terms: northbound interface, southbound interface. And the reason we have northbound and southbound is that typically when things are drawn, the equipment gets drawn at the bottom of the page when we have controllers that go with these things. So southbound, if you use a compass rose on a piece of paper, southbound goes down, northbound goes up. Northbound is going to be here connected to the applications. So the southbound interface are going to send the information from the controllers to the devices. Northbound interface is communication between the controller and the applications. And I said, we're not going to talk about an application layer, but we are. Management plane. The management plane here, that's us. The management plane has kind of come to mean the protocols, the SSH, the netconf, the restconf, the protocols that are used to communicate with the devices themselves. And then the application plane, which is not, I think, really officially endorsed, depending on which book you look at, are the applications themselves that are used for these things. So in the traditional networking, we go to each device one at a time. Control plane, data plane is there, management plane, yep, we're there with it. The software-defined networking, we're going to be going into a central machine, a central controller, like the wireless LAN controller, configuring it, and then it's going to send the information to the programmable switch, the device that's going to take those configurations. The controller machine itself, all of the things that, for instance, OSPF does individually, it's going to do for the entire infrastructure. So we're going to centralize management. And you might look at and say, hey, what happens if the centralized manager fails? You know, that could be a problem depending on the approach that you take. Cisco's approach has been more like, yeah, we'll use it to send the configurations for it to the devices so that if the controller fails, we can continue to run. The wireless LAN controller, if it's configured properly, can continue to run if the wireless LAN controller fails. By default, everything's supposed to go through it. So how we do the configuration can and will affect what goes on with these things. That brings us to the next topic, which are application programming interfaces. We'll look at a couple of those, but before we get into that one, let me see where we are. Yeah, before we get into that one, because we're going to have a couple of API topics, let's go ahead and take a break. Questions or comments, and come back at, let's come back at the top of the hour. So application programming interfaces. This is another one I think I want to look at, kind of an API program. It's one called Postman, another free piece of software if you want to do it. But what we want to do with Postman, let me get rid of some of this stuff that we have used. We don't need this one anymore. What we can do is get information, the concept of go get stuff and then come back. This is the one that ain't working. Let me see if the one that is working will do that. What we're going to do is want to get the interfaces here. The other things that we could get, and we'll look at another one here in just a second. ETF interfaces. Yeah. I'm not sure that that's the right command, but we'll see here in a minute. iOS, and this one is management back here, and this is what dash latest, I think. Again, this may or may not work. We're going to send it here. We can either send or send and download. So we'll send and see if we get anything back from it. It's not looking profitable here. I'm going to try this other one over here. ETF interfaces. The one that will work is this listing here, the sandbox, and I'll try the other one with one of the other get commands here in just a second. But this one I downloaded a little earlier, If we try to send again, it's not going to work. Just the tokens expired to show you a post, and we need to get a token here. So we're going to do a send here. The credentials, the DevNet user, the same one that we use, DevNet user, Cisco 123 exclamation. We're going to send these credentials and get a token. And when the token comes back, we should then be able to use it. We use a post to get the token, and then go to which one? Sandbox here, and in the header information, we're going to try replacing that token, and we'll send that. We should get a listing of the interfaces. We said it invalid character in the header. So, oh, yeah, I guess that I copied too much of it. Maybe not enough. Now I got the quote. We don't want the quote. Copy, and now let's try putting this in here and see if it works. And it says it could not send request invalid. I love it when they the quote shouldn't be in there, I don't think. Yeah. Did I get it? Did I get it all? Let's try it again. Yeah, it still doesn't like it. I'm trying to copy just the token. Let's try send again and see if we get a new one. Kind of like it sends the same one back and forth. So I should do a copy. This is one of those that, yeah, I just tried this out this morning and it worked just fine then. And do a paste here. And yay, I guess I finally got the right one. We got the interface listings, and this is in a sandbox machine that I'm going to give you a link in a little while that you can go look at the Cisco DNA Center. It's got a read-only version of it, but we have these process IDs, the PID here, the description, and the interfaces MAC address that goes on. I think that there are some other things that we can get in here, maybe a couple of things that we can get in here, /. Let's look at the network device, the devices that are here. So we have a response. In the response here, we have the square bracket, which means it's going to be an array, a list. And then we have an object here that's going to put together this wireless controller on down the line. And then we close at another object here, switches and hubs. The role is access, a Cisco iOS on down the line, iOS XE. So we can get a listing of the devices here, as well as the interfaces that go with those devices. Still want to try to iOS XE, and maybe it's a different port. Latest interfaces, Cisco. You know, this is the one that error timed out. It's just not going to go. The device that it's supposed to be connecting obviously is not connecting correctly, which means that I might have an issue a little bit later when we do these things. I wonder if it's just, I said 99, I don't know. Anyhow, we're going to try with the, when we get the intent base, we're going to try this one. And again, it may or may not work because the one that I usually use is not there anymore. So the API, the application programming interface, is an API. Nice definition here: collection of commands, functions, protocols, and objects that programmers use to create software or interact with computers. And that's what we want to be able to do, is to interact with our routers and switches, to be able to have consistent configurations, to be able to control a whole lot of them in the past. So I probably did do a copy instead of a paste, like Jamal said there when I did that. Programmers, you don't have to create all these from scratch. We're going to have object-oriented programming when we use these things. We're going to have software configuration kits, other users software development kits, SDK software development kits. Somebody's already done it. There's no need for you to redo it. So you can get these. A number of those are available to you if you want to start doing these things. Software-defined networking, the APIs enable the data exchange between the controller and the programs running between the networks. And we've talked about the northbound interface and the southbound interface, northbound APIs and southbound APIs. What are we going? Are we going from the application to the controller or controller to the device? And what we're getting to with this is like those lightweight access points, devices that don't have a lot of quote intelligence unquote, that the management, the intelligence, the control is done someplace else. It's just going to do the labor. It's just going to do the data shipping, forward data packets from one device to another device. So when we get in here, the southbound interface, communication between the controller and the network device, the northbound interface enables enables a program to obtain and process the information from the controller. So the management plane, and this shows an eastbound. We've got multiple controllers here, SDN controller, software-defined networking. Software-defined access is the term that we would use for these things today. So in these, we have management plane, control plane, data plane. Those are the ones that you want to take with you, at least for today, when you do these things. And you're going to see the term application plane. Application plane, and what they've gone to, I said in at least some of the books, is we have the applications here, and I think probably even in the Boson NetSim. I'm just trying to remember where I saw all that. The applications are at the application plane. The management plane, they talk about the protocols that are used to connect the applications to the control plane. Control plane is going to control the data plane. The data plane is just going to, what's going on here? The control plane, if we will go back to OSPF, this is where the infrastructure would have been defined. This is where the Dijkstra algorithm would run. This is where we would determine the routing table. We would then send the routing table information, actually the forwarding table, to the data plane device. It would then use that to control the data going from one interface, the switching one interface to the other, incoming interface, outgoing interface for the data itself. When we do those things. So the southbound interface sends the routing tables, the MAC addresses, control information to the devices, and the northbound interface gathers the information from a controller, programs the logic used by the controller to maintain the forwarding tables. What may be expanding what can happen here based on some of the stuff that we've seen. So we can collect information from the devices, and we can put that information into tables or into some sort of a data storage area. We can then use the programs that are available and the templates that we might want to use and modify what's going on the devices. So more automation. What can we do? What can't we do with the devices themselves? The planes that we have, the type of planes, the data plane, the control plane, and the management plane are going to be used for these things. Separation, to program and manage operations either in a distributed or a centralized manner. The distributed means that we go to one device at a time. Centralized management, sending the commands to the devices from our central location that we would have. What that might look like in the things that we've talked about here, the planes themselves, the adjacent routers here the adjacent router, the control plane, and the data plane. The management here, the management policy plane, and again, different terms, but management plane, we're talking about, that's us. That's where the management takes place. Configuration, command line interface, the GUI. How do we get to the device? We're going to have some protocol. The GUI that we used in the wireless LAN controller, and then it used its CAPWAP tunnels in order to send the information to the management information encrypted to the lightweight access points. So we the management plane or the management plane uses one of the available protocols to connect to the control plane. Control plane, this is where the static routes, the OSPF, the process is going to take place. So OSPF here would normally share at the control plane on the device, would share information with the adjacent routers, with the adjacency table for those things. In the larger concept of this, the controller, the DNA center, for instance, is going to know what all of the interface values are for these devices. It would have collected that information. So it knows that this device has a gigabit port and what it is, and it has a 100 meg port, and it has a serial port or whatever else. So it's going to know the cost of each of the devices. And because it's collected this data, it's going to know how the devices are connected together. Since it now has this information, and it has it for the entire network, so we're talking about some significant processing power here. It can calculate on its own the best path. The control plane, the controller will do the quote intelligence unquote, will do the calculations. It's then going to send the route or the switching table. We're going to have in the routing, we got the routing table and the switching table. They're essentially the same, but the switching table says if it comes in on this interface and is going to that interface, which is exactly what the route table does, switch these two interfaces together to forward it out. So the control plane will provide the data plane, the physical device itself, the one that's going to do the work, the forwarding table, the routing table, the switching table. Forwarding table is going to be at the data plane. In switches, hey, how about MAC addresses? Well, it's going to know already what all the MAC addresses is for all the devices, so it can construct the MAC address table and give it to, or forward it to, give it to the device itself, so that the switch knows which interfaces to switch together when one device wants to go to the other device. Another kind of what protocols run at what planes here, the layer 2 protocols, spanning tree, LACP, the link aggregation control protocol, UDLD, CDP 802.1x, different things are going to be there. Layer 2, the STP, the spanning tree states are going to be there. The MAC address table, what the device needs in order to forward information from one device to the other device. Layer 3, routing protocols are what you see in there: OSPF, BGP, EIGRP, HSRP, the hot standby routing protocol, VRP, ARP, or all things are going to be at the control plane. What does the device need? It needs the forwarding information base and the adjacency table. I know what it knows, what's connected to it. There are also some for storage products, which aren't really a topic in CCNA, but there are protocols for the storage products that we would have also. The management plane over here, in the management plane, you see the protocols that we use: the SSH, secure shell, telnet, SNMP, XML, remote monitor. So the management plane, and this one kind of at least implies that it's the protocols. And then we're going to have maybe a program that would use that management plane protocol to send changed or updating information to the control plane to do these things. So the different planes and what automation does is separates these things, separates the plane so that the physical device doesn't do the processing. We don't have to worry about getting in an OSPF that, hey, we're going to have a DR, a designated router, and it's going to need more processing power. It's going to need more memory. It's not going to need more capability, because all of that information is going to come to the devices from the control plane to do that thing. And in the management plane interface, automation, the management plane, and I think when you for what we're management plane, management plane, think of it at, well, I always say that it's us. It's the configuration that goes to the control plane. When we had the wireless LAN controller, you connected via HTTPS to manage it. So the management plane was the HTTPS protocol. We had to have something to input the instructions into. So there's going to be an application that's going to be associated with that protocol, if that kind of makes any sense there, Jamal, when we do that. But yeah, when you do the review questions in the BOSUN, and this specificity has kind of evolved over time as to what it is, and that there isn't an application plane, and then they say, well, maybe we really need to add this application plane. But right now we're going to have management plane, control plane, data plane, and the applications are going to connect to the control plane via the management plane, if I can confuse that anymore for those things. So the data plane, the collection of tasks to be performed by a device. It's going to handle the data. And what's it going to do down here? Let me do the other bullets here, and then we'll look at the table. The data refers to the frames or the messages. Forwarding data is the most important task, probably the task that is going to be here, and sometimes it's going to be called the forwarding plane. So what are the real-time functions? And that's what we're talking about, real-time functions here. For the routers and the switches, add and remove the 802.1q headers. That's got to be done as it leaves the switch and goes into the trunk, or the VLAN trunks. Routers and layer 3 switches, encapsulates the packets into frames. Layer 3 switches matches the IP address to the destination of the destination to the routing table. Doesn't construct the routing table, it uses the routing table. Layer 2 switches the MAC addresses, doesn't create the MAC address, doesn't have to look at the MAC address, accepts the MAC address, and it matches the MAC addresses and forwards them directly to the port where they should be. Access control list filters the packets, drop the messages that don't meet the restrictions, the criteria of it. And then that translates the IP address of the source or the destination. VPN encrypts the data, adds the IP headers for the VPN processing that we would use. And this is the mighty switch. And I think we referred to a couple of times that switches use hardware in order to do switching. They don't switch in software because they'd never be able to do that. They'd never be able to get there. Large number of frames per second. And then if you think about it, how many frames per second could this be? So if we've got a 24 port switch and each of them running at a gig, and each of them actively running at a gig, they're all in motion at the same time, and 125 bytes in a frame. This is all calculations to make the arithmetic easier. Each frame is going to be 1,000 bits long, and with a speed of gigabits per second, a port sends 1,000,000 frames per second when we do these things. Full duplex on all the ports. Expect to receive on all the ports and send all the ports simultaneously. So each direction, we're going to be sending 1,000,000 frames per second for these things. So the switch, the data plane, needs to be ready to process 24 million frames per second. I said a billion, that's a million. Losing my mind here. 24 million frames per second for each of the ports. And that'd be in each direction when we do that. Faster data plane obviously is going to be needed. So the CPU couldn't keep up with that. And that's where the ASICs come in, the application specific IC. That's been doing this plain business internally for a lot of time to switch it to the data plane. The CPU is going to find or develop or discover the MAC addresses on the ports and then provide that to the TCAM table, the temporal content addressable memories, like the MAC address table with other information that goes along with it also to do that. So when something comes in here, the ingress interface, the switching ASICs, CPU memory is going to have the information. The CPU and the memory are going to provide information to the application specific ICs. Yeah, the first time through, it's going to provide the MAC address. Some information, the iOS is going to be running in memory, but the switching is going to take place independent of the CPU by the application specific, the ICs themselves. Once they get the information, it's going to go into the TCAM table to do the lookups. That the switch needs a faster data plane. So the data plane is going to be where the work takes place in here. The CPU is not going to be able to keep up. Always had the specialized data plane. The switching logic is in the ASICs, not in the CPU. The ASICs, the special purpose chips. And that's why when you get into something like a GNS3, you can't really emulate switches. You can simulate them in a BOSA NetSim or in a packet tracer, but to emulate them because they need this chip in order to actually do the processing that goes on. Needs to perform the MAC address table lookup, and it uses a special memory, the ternary content addressable memory of the TCAM table. No looping is required. The ASICs feeds into the TCAM, and the TCAM returns the matching entry for it. Still got the CPU, the RAM, the iOS, and those are the ones that are going to keep the system going to support the switching that goes on within the special areas for those things. The control plane actions that controls the data plane, which is kind of using the word to define itself. The control plane is where, and I say the quote intelligence unquote, it's where all of the calculation goes on. So the data plane doesn't have to do any of the calculations or determinations. It doesn't have to determine the routing tables and all that, the MAC address tables. That's all done at the control plane. So they need routes. The control plane is going to do the route calculation, send that information to the data plane. It's going to use it to do the forwarding of the information from, or actually switching interfaces together to go from one to the other, to send the information out of the correct interface based on the routing table that it was provided. This might be something like maybe, I don't know, maybe somebody that's delivering things, trucking. We're going to have somebody that gives you the route to take if you're the truck driver to take your cargo to a specific location. So the control plane is going to be the one that's going to provide that information. So we need the IP routes. The layer 2 switches need the MAC address table. We need the spanning tree information. OSPF manages the routing tables in the control plane of the router, and then the data plane is going to use that information that has been provided to do the data shipping from one to the other. Commonly used protocols in the control plane: IPv4 ARP, IPv4 neighbor discovery protocol, spanning tree, MAC address learning, and switches routing protocols: OSPF, RIP, BGP, EIGRP. The type of control plane in which the control plane actions are distributed among the networking devices is going to be called the distributed control plane. And that's where we're trying not to go. That the distributed control plane, each of the devices has its own control plane, has to do its own sharing calculations, OSPF to determine the shortest path first tree, and then determine the best path. Protocols, network devices function to help separate these two planes. Control plane enables the data plane to work efficiently. The control plane sends the information to the data plane, and I guess there's probably not too many times that we can say that, but that's where we're going with these things. So the collection of protocols that enables the management of the devices is going to be the management plane. Common protocols, SSH, SNMP, syslog, telnet. How are we going to connect these devices together? The management plane enables management of the devices, and this is where some things kind of become nebulous at some times. Management plane protocols are not essential for the networking devices, but they are necessary for changing the network devices. Because if we can't SSH or telnet or send SNMP messages, we can't make changes to it. So the management plane, yeah, it can go away for a while. It's just like you do the configuration, you're the management plane, everything on the single device, you make changes to the device. You don't have to be constantly connected to it, and you're not constantly connected to it. It goes on and does its work without us directly connected to it. SNMP, syslog in the management plane are going to help to troubleshoot and diagnose problems, and we've seen some of those things, perform maintenance tasks. And this may be one of those that, yeah, you get an error message and we do things, but it gets information and it's programmed that if this happens, then make this change. And this is kind of where I think automation wants to go. And we do that in other things. So if we have a virus that comes on, then the virus checker says, hey, let's take care of that. Let's kill that particular virus. Happens automatically. So something happens in the processing, if this, then that sort of arrangement in programming that would go on with these things. The API interfaces, and I probably jumped the gun on my other one here, but we have it and we have done it, and we've looked at the API and kind of what you can do with the API. Web service APIs, and we looked at that one, created in XML, usually maybe created in XML. That's the only page on that website that actually uses XML. But you can use this, and that's maybe for constantly changing information. You don't have to change the web page, you just have to change the data, because we have a template there that's going to extract the data from the, using the template, extract the data from the data file that we would use. Don't depend on a single operating system or programming language for these things. Categorized by products or standard: XML, RPC, SOAP, and REST. Representational REST is where we're going to go. Representational state transfer for these things. So web services for this one through HTTP, HTTPS. And we're going to continue to use this protocol to exchange that information. Just some XML, what we have: extensible markup language, remote procedure call, RPC for these. What this is supposed to represent is we've got code, the HTTP, the XML, the data code here, the HTTPL, the XML code, sharing information through the remote procedure call that goes along with these things. Control protocol uses the XML to encode its calls and the HTTP as a transport mechanism. So another XML, there's a number of XMLs. This one is Simple Object Access Protocol. What this is designed to show is that XML has some restrictions, has standards that they have to be met with these things. We have the client, the data, the SOAP standards, and then we have the SOAP standards here and the data that goes along with it to go to the server. The data sent to the server with the SOAP standards. REST is going to be more open, sending the data without the strict standards that are required when we use the XML. Representational state is a software that defines the constraints in the web services, provides the performance, portability, modifiability, portability for these things. We can have client server architecture, statelessness. These are the terminologies that define representational state. It's going to be a client server architecture. It's going to be stateless. We have to define whether the information is cacheable or not, cacheable on the client. A layered system, going to have a uniform interface and a code on demand. Code on demand is going to be one of the optional components of this. The DNA Center and the Cisco SD-WAN are going to be things that use these. The RESTful APIs, flexibility for the developers, are going to use the protocols in place on the IP network and decouple the data from the underlying resources. The data formats, XML, JSON, and YAML. JSON and YAML. JSON is the one that we really need to take away. XML, it's there, it's used, it's in use, but it's not going to be the preferred data format for these things. Less bandwidth than SOAP, the representational states for those. The HTTP verbs, and we've seen, and I think the CRUD abbreviation before, and this is the ones. There are other verbs that are used, but post, get, put, and delete are the ones that we're going to predominantly use. The verbs correspond to the CRUD: create, read, update, and delete are the CRUD verbs that we talk about for these things, and they're going to go back and forth. HTTP post, HTTP get, put, and delete in order to make changes and to delete objects. We did the post. The post was the one where I was asking for the token that I use, and then the get, we use the token as the identification to get from one to the other. Not a real readable one, but SOAP versus REST, the comparison, and this is which is right for you. These are one of the multitude of things that you got to figure out which ones that you need to use on your very own network to go from one to the other. The next one is going to be a series of intent-based networking. I think what I want to do is take a 10-minute break here. I know it's not quite time yet because I need to get the other ones set up so I can try to show you what we're really talking about there. Questions, comments, and see if it will actually work with the other Cisco device. I think I'm can't actually make it work. I can show you what we're going to be talking about with intent-based networking. So when we talk about that, there are some specific application programming interfaces that go on in it, and the intent-based APIs, and this is the Cisco DNA data center performance, and the things that we would use in order to do the connectivity here. For the authentication, we're going to post to get the token, which is what we did. The sites, to get the sites, the information that's available. So these intent-based DNA intent API, the APIs are stored someplace. So we're going to have the interface to get that information from one to the other. Intent-based says, this is what I want it to be, not necessarily what it is, but what I want it to be. We go back over here and I can't find the port, and I'm not sure that it's actually opened back up to, as I said, they had this here for the longest time, and all of a sudden it's not there anymore. But when we would look at the YAML file here for this one would be the DevNet YAML. So we can just nano dev.net.yaml. We will go down, and this is not going to be, the name is going to be add banner, iOS banner, banner login, configured by an ACI, and then the state. What was at least implied in the little video earlier this morning, the state, it's either going to be there or not, absent or present. What is my intent for this particular one? And just there's a couple of things here. Add backup, and this, the absent here was to take them off. The first would be present to make them work, and then absent to take them back off. They've obviously done something to this one to not allow me to get on to it. Actually, this is a different sandbox iOS. Well, anyhow, if I can get it working before we get done, we'll do that. One of the things that we can do is go back to some of the scripting that we might use to get to that one, because the scripting is going to be a little bit different. Root, get into this guy, maybe. So in it, we should be able to go into here, and I think get info, and that's what is up there, the Python 3 to get the info about this particular area. When we go up here, you can see that it is in JSON format, and we'll go all the way up. And this is one that it's still there and people can use it, but I don't know what port it's using in order to get to it for the other one. If we can nano this one, which is get info, we just go here to the iOS, and I changed it from the one that I had to the latest, the REST-conf, maybe it's just without a port, REST-conf data to get the interfaces, which is the specific API to get that information that we would want to use, the response, the user, authentication, user and password, which I defined up here, the developer in the Cisco 1, 2, 3, 4, 5. We can go in here and add an interface. And let's say I got the get info create interface. So we could use Python 3 create interface.py, and it said 201, response text 201 says yes, this worked. And now we could go back and use the get info. I guess I should look and see what we create. I think it's 707 or something like that. Let's do a nano of create interface. Can't gotta spell it right though. Cano, N-A-N-O, create interface. So we created, added by an ACI learning class. So we should be able to get that information. Loopback 707 has a comment with it. So Python 3 get info, and in here, here's our loopback 707 added by us for this thing. I didn't put an IP, I did two IP address 1.2.3.4 with a 255.255.255.255. So kind of what we can do and can't do with these things. So since I added that interface, and what they always say is be a good citizen here, Python 3, and we'll delete that interface. Python 3, I still got, but you can see why I like completions. Python 3 delete interface. So it should then take that interface off. The status code 200s that come back are good. Those are the ones that we would really want to be able to see for those devices. So not exactly intent-based, but it's kind of intent-based. Intent-based is going to use the API. What is our intent for these particular interfaces, these particular pieces of hardware that we would use? So intent-based networking for those, the controller-based networking northbound interface, us, scripts, GUI, whatever we're going to use, Cisco or vendor app, script or app that we write, whatever we're going to use to interface with this thing. The 2010s, the software-defined networking, which allowed us to do scripting to make modifications. And just as an, oh, by the way, we've got a big thunderstorm just started, so hopefully I'll be on for the rest of this. But if I don't, if I go away, I'll be back as soon as I can. 2010s introduced software-defined networking. Use of the controller to centralize some of the functions that happen with these things. Controller created some new capabilities that went on, enable the configuration through the application programming interfaces. The applications to the northbound interface, manage the controller southbound interface sends the information to the device. The thing that we've said multiple times here today to go from one to the other. Traditional networking, yes, we configured one at a time. The basics for these, the traditional networks made up of specialized hardware, router, switches, and bundle the networking and software into the solution. SDN separates the software from the hardware and makes it easier to innovate and adapt for these things. Some of the definitions, the underlay, overlay of fabric. So we're going to talk about the fabric first, and I thought we talked about the, we'll get the overlay and the underlay. The fabric is an overlay network or virtual network that's built on an underlay network. The underlay is going to be the equipment. The overlay is going to be the logical path that the data takes through these things. So the fabric is kind of the combination of that when we do those things. The shortcomings of the physical networks, host mobility, network automation, and then virtualization and segmentation are going to happen with these things. Two implementations of this: software-defined access for campus networks and software-defined WAN for the wide area networks. The terms, and these are terms that you're going to have for that one, and there's nothing magic about them. The overlay to create VXLAN tunnels. The VXLAN tunnels, new terminology, new terminal, is just the kind of header that it uses to determine the path from one to the other through this thing. The underlay is going to be the physical devices themselves, the devices, the cables, the switches, and the connectivity that goes along with it, with the goal to support the dynamic discovery of all of the SDA devices and endpoints, and then create the overlay of the VXLAN tunnels. The fabric is a combination of the overlay and underlay, which is probably not a very good definition, but that's the one that you're going to see. So a combination, components of each of those is going to be the overlay, or the fabric here. The overlay network is going to be a virtual network built on top of another network connected by virtual links. So the tunneling that we're going to have, and the tunneling is going to pick the paths to go from one to the other. How do we get from this network to that network? We used to have switched virtual interfaces in frame relay, and it's conceptually it's the same way. If I bought one of those, we had a switch network, and it would create the interfaces together to get from point A to point B. We're going to do the same thing here with VXLAN tunnels. The underlay is going to be the physical structure that goes on. Some software-defined applications can be on the existing network. Existing switches and routers, the technology is going to be linked to the physical devices. They're going to get into, and I don't remember if it's still in this presentation or not, that some of the new concepts, they recommend that you not migrate, that you're going to have a hardware compatibility list, that you buy the hardware that's going to be compatible with these things. The APIs that we had, you had to have specific OSs, iOSs in order to be able to use that, the iOS XE, and that's why the one that I've been working on is kind of so frustrating that goes on with these things. So can improve the flexibility and the management options that go on to this thing. So not a real dramatic picture here. We're going to have the underlay, the multi-layer switches and the links with the IP connectivity is going to support the new concepts, tunneling method, the new tunneling method, the VXLAN, different tunneling method for these things. The data sent by the endpoint devices flow through the VXLAN tunnels in the overlay. So when we talk about virtualization, the VXLAN, the virtual path to go from one to the other, the system, the protocols that we use here are going to pick the best path for the data to flow through this physical devices. And back to virtualization, at some point we got to have physical devices. So at any point in the virtualization process, at some point we're going to have physical devices that allow the management to pick the best path to go from one to the other. Exist to provide connectivity for these things. The fabric here is the topology where the nodes communicate through one or more of the interconnected switches, and then the switches may often form a mesh network to provide the redundancy for these things. And when we would do this, this shows layer 2 switches. If we form this redundancy, and usually in the VXLAN topologies, you're going to use layer 3 switches. So you don't have to deal with spanning tree. To have the blocked and then something happens, oh yeah, I've got to wait for the spanning tree processing to take place in order to bring it up. Layer 3 switches, we can use layer 3 addresses. We need a layer 3 switch at the access layer if we want to, and it becomes the gateway. We don't have to go someplace else for the gateways for those things. Obtain the fabric that's been integrated with the technology, and then this fabric can and will be more application aware for these things. The SDA, software defined access over LAN sequence, is the endpoint sends a frame, my device. The first SDA node encapsulates it into the VXLAN tunnel and puts the header information on it. And I have some other looks here in a little bit about what we're really talking about VXLAN tunnel. Not that you need to know it, but give you an idea of the kind of processing and why we do this kind of processing. Forwards the frame in the fabric, and once it's encapsulated, the remaining nodes forward it based on the VXLAN details. One of the things that this does, we have the IP, the UDP, the VXLAN header, and then the frame. The whole thing gets encapsulated. What happens here is that when you're doing IP addresses, which we're doing here, you don't have to read as deep into the header. It puts its own more readily readable, maybe, header at the front end so that the path through the tunneling cloud, and this is generally, this is going to be large scale, obviously, when we do these things. So there's going to be a large scale to create these VXLAN tunnels, and generally going to be through the cloud. So we're probably talking about ISPs for the most of the implementation of these things, not the enterprise when we do that. Underlay, overlay, same thing. The underlay is the physical devices. The overlay is the path that it takes. This one, overlay, underlay, which kind of goes like crazy around and around and around. What we might have here, we have path 1, server to server, path 2, path 3. But through the physical devices, what might the paths be? And path 1 here, we have to have, going with a virtual device, we have to have at some point a physical path. And then path 2 is going to go in an entirely different direction. And then path 3 in yet another direction. And I got my arrows going backwards, but you get the idea that we go from one to the other. We have the end users here, and then the autonomous systems, the underlay network versus the overlay network. The overlay network looks much simpler, but underneath we have to have the underlay. How does it get from device the device? What's the path that it's going to take? And how does it determine that path? One of the things that's going to happen here when it starts, a couple of terms here, VXLAN overlay, the underlay, the layer 3. We're going to have a device that's going to keep track of everything, kind of like a registry that goes on with it to be able to do these things. So in these, the VXLAN tunnels, the virtual switches, the server IPs, VXLAN tunnels through the cloud. The complexities of the cloud are going to be simplified with these things. So when it gets to the end devices, where you go in, and then it's going to put the header information on it. Okay, these are the paths, or this is the path. This is the VXLAN tunnel, and the VXLAN tunnels are defined through the devices that would go from one to the other. So virtual extensible local area network for these things, the VXLAN tunnel. But what goes into it? We got the outer outer source MAC or the outer destination MAC. And when we get encrypted, the source and the destinations now become the devices within the VXLAN infrastructure that we would use. The source IP and the destination IP, the UDP, the VXLAN, and then we get down to the data that goes along with it. The TAN here is going to be the data that comes into this thing that gets encapsulated, and then the header information. How are we going to go from one to the other based upon the information that goes in there? Encapsulates the layer 2 frames in a layer 4 UDP for these things, and then has a layer 24 LAN identifier. Rather than the 12-bit VLAN ID that goes on with this thing. So going from when we get in here, host A, when we get into the VTEP, where you going? We got the destination IP address gets encapsulated. The VXLAN ID gets put on this thing as to which tunnel it's going to go through to get to the destination. So lots of configuration goes on with these things. More of what we would have here, VXLAN encapsulated frame, the outer Ethernet MAC address, which is going to be the outer down here, the VXLAN type. It's kind of the same information that we had before, except more specialized here. And then the outer IP, and after that, the UDP header that goes in here, the VXLAN header that goes in here, the VXLAN flags, the reserved, and then the VXLAN network identifier. What tunnel is it going to use to get from one to the other? Then the data payload, and at the end of this, we're going to have the frame check sequence that would go along with it. One other, the DNA Center, which shows up in a number of places. The centralized management platform provides dashboards for management tasks and the controller management analytic capabilities, and the components, the Cisco SD Access, the Cisco SD-WAN, and the Cisco Assurance that would go along with these things. One other video, if I can find it, another Kevin Wallace video to get an idea of what this does, and I'll give you a link for a few minutes to look at what it is. Let's see, DNA Center video, and it may be loud. I can't control that volume. So one more time, and my volume's down to like 30% on my device, and you saw me turn the volume down here. It's down to very low on the video itself. They're very loud on me also. So let me turn me off.
In this video, we want to take a look at a way to manage our network using a graphical and a programming interface. It's called Cisco DNA Center. And Cisco DNA Center is an appliance that we can install in our network, or there's an option for having DNA in the cloud. But this is going to give us a graphical interface and a programming interface to design our network, to add devices, configure devices on the network, monitor, troubleshoot our network. And I know Cisco in the past has had other graphical front ends to router configuration, such as Cisco Configuration Professional, but this is just way beyond that in the scope of what it can do. Let's take a look specifically at some of the main areas that Cisco DNA Center focuses on. First up, there's design. With design, we can take a map of the world and we can add an area. And we could say within that area, we've got this building, or there's another area within an area. We can put a floor on a building. We can import a floor plan, and we can drag and drop devices onto that floor plan. We can say what our IP address allocation is. This is a way for us to design our network through this graphical interface. In addition to that, Cisco DNA Center can apply policy. We can assign policies to an entire group, maybe allowing or denying them access to something. We could do IP-based access control. And one of my favorites is quality of service. We can set up a queuing profile to say what bandwidth amounts are given to different applications. We can also do provisioning with Cisco DNA Center. Here we can essentially do plug and play for our devices. We can have a new network device sent to whatever location where it's going to be installed, have somebody there plug it in, and when the device boots up, it's going to go out and get some IP address information from DHCP, including some DNS server information, and it's going to resolve the IP address of a DNA Center server, and it's going to go up to that server, and based on its serial number, it's going to be able to download a configuration file. So we pretty much had zero touch on getting that thing installed. We just set up the profile of that device within DNA Center, had somebody plug it in, and it installed itself. Another big part of Cisco DNA Center is assurance, and this is where we can monitor the health of the network. This is going to help us with troubleshooting. If there are existing faults, we can see what those are, and based on experience of Cisco Tech, Cisco DNA Center is going to give us feedback about what we should do to try to resolve this issue. And it's got a path trace tool in it, so if we're not getting from point A in the network to point B in the network, we can say, what if I tried to do a ping, or what if I tried to do a telnet session between these two devices? What would happen? Let's say there's an access control list in the way that might be blocking that traffic. Well, it's going to give us a graphical representation of the network and show us exactly where that ACL lives that's blocking our traffic. We can also do something called network time travel. So if there were some sort of an issue that came up at 2 a.m. last night, we could go back in time and see what was going on in the network at that time. And one of the most powerful things about Cisco DNA Center is its ability to act as a programming platform. We have a large collection of APIs, application programming interfaces, that will allow us to do via a program what we could do graphically. If we want to provision or set a policy or gather troubleshooting information, we could do that with a Python script, for example, using some of these APIs. And obviously, Cisco DNA Center is very, very robust, and there are weeks worth of training you could take just on DNA Center. But just to give you a sense for what's possible, let's go out to Live Interface and look through some of the menus. Oh, by the way, as a comparison, you may have heard of ACI, Application-Centric Infrastructure. That's Cisco's management platform for data centers. Well, think of DNA Center as Cisco's platform for managing enterprise networks. Again, think ACI for the data center and think DNA Center for the enterprise. Now, let's take a look at DNA Center. We'll go ahead and get logged in. And here we see those things we were talking about a moment ago: design, policy, provision, assurance platform, and those are our menu options up at the top as well. For example, I could go under design and we could pick an area of the world, maybe under US, for example. I could go in and I could add an area, perhaps add an area for Kentucky where I'm located. We'll add that. Then I can add an area under Kentucky. And we could say that's Richmond. And within Richmond, I could say I want to add a building. So we'll say we've got the headquarters of Kevin Wallace Training, KWT. And it wants me to put in a specific longitude and latitude here, so I'll just guess at what that is. And I could import a floor plan, and I could also set up policy. I could set up IP-based access control for my access control lists. One of my favorite things, though, is under application, I could do a queuing profile. I could say I want to add a profile, and for different applications, I could say, how much bandwidth do I want to give those different applications? Under provisioning, I could go in and set up a device to be installed to the network using that plug and play operation like we talked about earlier. I could say I want to add a device. Under assurance, this is where we can do our troubleshooting. This is where we can monitor the health of the network. And if there are outstanding issues, we could see those issues and get some suggestions for what we should do to fix those issues. And we could go back in time using that network time travel to see what was happening in the past. And under platform, this is where we can do some of our development. If you go under Developer Toolkit, check out all these APIs that we have. Let's say under Know Your Network, we could have an API to go out and get a list of devices on the network. Under Site Management, we could set up plug and play. Under Operational Tools, we could do the path trace that we were talking about. And obviously, this is a super high level 30,000 foot view of Cisco DNA Center, but the purpose of this video was just to help you understand what DNA Center is. It's Cisco's management solution for the enterprise, and to understand some of the things it can do. And those things fall under these categories: design, policy, provision, assurance, and platform.
Get him off and take just a couple of minutes. We don't have a whole lot left here this morning. If I can find the document that I'm looking for. I got too many things open. I'm driving myself crazy here. Here we go. So DNA Center, you should be able to get to a read-only copy at this address and use these credentials to log in. The interface now is a little bit different than the interface that he had, but just what's there. So take a look there. Take probably about, I don't know, let's take till about 15 minutes to quarter. Let's take a quarter of the hour, and then we'll finish up these slides. While you're doing that, I finally found the port number that this one uses. So try this intent-based. So what we'd have to do is to modify the YAML file that we have, so we can do nano devnet.yaml here, and down here to add banner, and the state that we will use, I hope, is going to be present. And we can go down here and add this interface, loop back to 11 and make it present. And then with any luck, we could go into the Ansible playbook, and it is devnet.yaml, because at least it didn't throw me out a minute ago when I tried that. Ignoring some stuff. So task, it says that we got there, add a banner and add the loop back, says that it is done. So let me get a putty going here, and let's try to SSH to that location, and it's ios.exe.dash mgmt dash latest.cisco.com. So log in as, and maybe we didn't, because I should have had a login banner, I thought, developer. And oh yeah, here we go. Configured by an ACI learning class. Ansible demo. So we got there, and then a C1 SCO 1 2 3 4 5. So we can show an IP interface brief for these, and we were what, loop back to 11 here. We just here we didn't do any IP addressing or any of the other stuff on it, but our information is there. So let's get out of that session and let's go back and take it off. I know this is just a, okay, so you put it on, now we'll take it off. And it is always, when you're doing with these public ones, and they say, and they do ask you to do that. So it'll be absent, present or absent, whatever we're doing for these things, the different intent. My intent is for it to be there or not be there. And now when I do that, modify the buffer and go back to the playbook, it should go ahead and take it back off when we got there. It's gathering the facts. So it says that it had the banner, it said it had changed it, and then and changed two items. It says that we actually did do the modifications to it. So the DNA Center, and maybe the overview didn't mean a whole lot, but what you can actually do with it, it is a large scale. And I didn't get a price list here, but the price lists go from like $50,000 to probably $150,000 for this thing. They got one that says free, and I have no idea what you have to sign up for to do that. But the SD access or software defined access, automating one policy across the entire network. The DNA Center, the APIC EM controller that he talked about. And again, if you want to see what it is, the APIC EM, it's one of those things that the DNA Center has kind of overtaken it, but policy provisioning, design, and assurance that can be used in the DNA Center as we had in the video there. The switches, the routers, the wireless LAN controllers, the fabric is going to be the APIC EM from one to the other, the identity services model that goes from one to the other. The software defined WAN, some of this is just where are we doing it? Are we doing it the WAN fabric or the LAN fabric? The LAN being a pretty large network that we would have. And in this one, we're going to have the secure connection from any user, any application, anywhere that we have within the cloud for these things. And assurance, the guarantee that the infrastructure is doing what we intended for it to do. Analytics going to be combined with automation to reduce the time spent in the troubleshooting. And then assurance was one of the primary functions, I guess, focus that we would have in the DNA Center. So the learning here, the DNA Center that we would have, the whole network, powerful security sensor, at least we hope, with the Cisco security. And this is, what was it, Firepower is the one that we would use, they would use as the Cisco entity for these things. Integrates with the security operations to detect and contain the growing threats that we have for it. So the Cisco Stealth Watch, network visibility and security analytics for the detection to contain these things. And then the Trust Sec is going to enforce the security policies that we would have. Brings us up to